Dear participants, we're happy to be here today on this stage and present the AAS.TwinEngine to you. If you remember back in last year and compared to what we will see today, you will see a lot of changes, a lot of improvements. So the two of us, that's Markus Schüle, it's me, Rolf Engesser. We're both working at M&M Software. We are both in Competence Center Industry 4.0 and Digital Twin. And let's go ahead quickly. We have seen a lot of candidates today, a lot of great solutions out there. We think we differ slightly, not slightly, massively in some extent. And we want to tell you what was our motivation for taking a very different approach. Basically, we are not presenting to you something like a closed product or solution. Instead, we are offering an integration framework. For the reason we want to seamlessly integrate into existing software landscape rather than having something isolated around. We will tell you about what is our understanding of secure by design. And we will emphasize the need that we want to have this available to be run on deployed and run on any environment, not restricted to some runtime environment only. Also, very crucial point, our data that we will retrieve via TwinEngine will be real-time data. It will not be outdated, expired data. And we will also like to take you and share our proud on the approach we took for the data-driven architecture and all the benefit that comes also in operational level and also saves a lot of costs in the end. So it's not only beautiful, but it's very efficient in the end. So, left-hand side, this is what, to be honest, we did a major change. Left-hand side, this is what in an earlier version we came up with an existing platform, in a data integration platform, a very major platform in place. So we considered a bundle of such a platform plus what we will see on the right-hand side. We found this is for a lot of customers, this is a hard limitation. They tell us we do already have something like that in place. We do not like to accept such a vendor login. And this is why we decided to switch to a plugin architecture. Means we can connect to any such environment. We have built for some of our customers some, let's say, specific data solutions based on technologies like semantic web, graph databases, which we then comprise into an enterprise knowledge graph. And here in such situation, we would have a GraphQL endpoint, which we can connect the data. It could be some microservices, and you would set up something like a federated GraphQL endpoint, which allows the access to all those data. It could be, let's say, a very major market player like Microsoft Fabric, and you would not have the need that you start thinking of how can we set up all the bindings, how can we create some rules to get all the data in a shape. But it's something you will have to do, and if you are not ready for such, as I said, we also can support you on that part. And then once that is given on the right-hand side, this is now where we do the AAS part. Left-hand side, so far you do not have to care about all the, let's say, AAS models so far. You will have a need to agree on a harmonized enterprise domain model across your company, because you can imagine, or you can, all the diverse systems that you want to connect to do not share some common data model. They all have their specific domain model, and you have to harmonize, transform it into one, let's say, fully integrated data model, enterprise data model. So far, you can connect internally across your system landscape, internally in your company, but you cannot connect and you cannot interoperate with some partners. That's where AAS comes into place, because here we do have the technologies, we have the submodels, we have the use cases, the agreements, what use cases are or what submodels are we have to use if we want to do such connectivity. And so this means that is what we will have to model and then connect via the plugins to the data that comes from the backend. How this will be working in more detail, this is what will Markus tell you.
So, hello together. I now have the honor to show you a bit more in technical insight, to give you a bit more technical deep dive. I've brought up the core components of our AAS.TwinEngine. Here on the left-hand side from the plug, you can see the plugin and the data source. This resembles the left box that from a slide that Rolf already showed. So the plugins, they are the connectors to your existing data sources. We know that everybody of you already has data and has processes in place to provide this data, and we now only add some small plugins to source this data. And everything that is AAS related is more in the center. And I now guide you with a request through the whole system to give you a bit more feeling how this is working. So on the right-hand side, we have the API user who is requesting something, an AAS or a submodel, and this request will be handled by the AAS gateway here as a centralized entry point, providing all AAS services. This will be forwarded to the data engine, and the data engine here is really the heart of our system. The data engine now has the responsibility to create asset administration shells or submodels on the fly, on request, with live or real-time data. And for this, first it needs to fetch a template to know about how the AAS or the submodel should look like in the end. And we are utilizing a submodel or AAS template repository. This offers a great opportunity to have different templates in place. This means if you think of different types of products that you have in your company, then you can specify rules to use a different kind of template for every request for every different type of product. With this template information now on a data engine, the structure is clear, how the result should look like, and the data engine now needs to request the data from the plugins. And as already mentioned, they are just connectors to the data sources, so they will do a request and return back this data to the data engine, which can now fill out a template. So we had a template without any values in it, and now we added the values. So we have a full AAS or full submodel and return this back to the API user.
Now you have some understanding about the function that we achieve by having established that framework. Now I would like to cover some of the non-functionals and what are the motivations, the drivers, and the business needs that are driving us very much in our decisions. So our understanding of security by design, that's what I like to cover here. Just imagine a situation, you come back home, you meet your CISO, your information security officer in your company, and you tell them, okay, I want to deploy a new solution. They will be very careful before accepting. Everybody who has taken this challenge already will confirm. So they will ask you, we will have to set up some new actors, some new users. You will have some additional interfaces. You will set up some new systems and services, and obviously this exposes new vulnerability, threats. Yeah, and this is why they will be very happy to hear that this will be nicely integrated in your existing service or your security model that you have already in place. For that, we have foreseen that we are connecting to any OpenID compatible identity provider. Could be Microsoft Android, could be Keycloak, whatever. Do not know any candidate in the market which will not satisfy that standard. The same goes for open telemetry. That's a critical point, because imagine you have some intruders and they are able then to do some harm your system and then to wipe their steps. Yeah, that is why such systems usually should be at some other place which the intruders cannot manipulate. So at least you can do some research what's happening. So based on that, we are now able then to connect via the OpenID to your existing system users, service users that you have in place. That could be users that are already privileged to have granted access to some of your backend systems. It could be a very simple setup that you say, we are good enough with one single user only, we are good enough with one specific role. So you also can create roles to your needs. But, it could be a situation that you have a huge organization, that you have shared responsibilities across multiple plugins that want to have the full control on their plugin, on their data, and for that purpose we would set up some service users for that. So that should make your information security officer more relaxed after that call to him. Next, we have chosen Microsoft architecture. An obvious choice here is Docker containers. What comes with that decision is we can deploy and run that solution, that services on any environment which is supported by Docker, which is almost anything. So you can run it on an edge device, you can run it on an IT, on a premise servers, you can run it anywhere in the cloud on some hyperscaler, or deep sea, some robot submarines, wherever. Like this picture. Have you ever seen a bee collecting nectar, flying home to the hive and taking rest? Have you ever seen the bees entering the hive and getting stuck in some bottleneck situation? Maybe you can remember what 2 minutes back, what Markus has shown you. We also do not have anything in between. Yeah? We are directly connecting to the data. We do not store in between. And for that specific reason, it's very clear we get recent data, actual data, frictionless. Critical point for a lot of use cases. And now coming to the highlight of taking this data-driven architecture approach. First, we thought about the obvious challenge is how can we bind or link the submodel properties to a piece of data in some backend system. First, we thought about something like we are doing some annotation in the submodel, like for property, we just annotate, okay, this is some points that takes you to the data source. Then we thought twice, and we found something better. And this is what Markus will tell you.
So coming back to the core components here, we have thought, instead of hardwiring the templates and the data that should be provided to the templates by the plugins, we came up with the idea to link the semantic IDs. You already have data in place, and that data should be and can be linked with semantic IDs. I think everybody here should already heard about semantic IDs. That's a pretty big thing in the AAS context. And so we thought, we came up with the idea to provide or publish the semantic IDs that a plugin can provide, and therefore the data sources connector can provide at the beginning. And this is just a one-time thing. And when the request then comes in, for example, for a nameplate, the data engine will request a template for that, so like shown already earlier. And now I have a template in place that contains no values, but it contains the semantic IDs and, for example, the manufacturer name. And because the plugins published earlier the semantic IDs to the data engine now knows that it can request the semantic ID from the plugin, which will return the value for it. and therefore the template can be filled out and returned. This gives us the opportunity to add as many plugins as you like. So you can publish semantic IDs here. And if you have a second plugin, you can just add it and it will publish its semantic IDs, and then you have a really loose coupled link in between the templates and the plugins, and you can update them independently.
So if the points that we mentioned, those capabilities are addressing your needs, and if you carefully check your let's say also the operational demands that you have, not only buying the box and then deploying it somewhere, but also what's beyond. Consider all those capabilities, and if you find some match, meet us. We are over there just a few minutes later. Thank you.